Alright, let's get started with 7.4, rational exponents. So, in this lesson, we're going to learn how to simplify expressions that have rational exponents. Remember, rational exponents are anything with a fraction or a decimal that ends. So, in this situation, we're going to be dealing with a lot of fraction exponents. Alright, and so that's what a rational exponent is. And so before we get started, a couple skills we're going to need: distributing and dealing with negatives. So I'm going to do number 1 and 3. You'll be responsible for the rest. So a negative exponent means that you can flip something over. This is 2 over 1. And then we're going to send it to the bottom. We'll have 1 over 2 to the 4. So when it gets sent to the bottom, the negative exponent becomes regular positive exponent. And then we can finish it. 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2 again, which is 16. 2 times 2 times 2 times 2. And then let's take a look at 3. 5x squared y is inside the parentheses, negative 3 on the outside. Alright, so let's start by distributing that negative 3 into all of the exponents here. Remember that there's a 1 and a 1 here as those exponents. So we're going to get 5 to the negative 3, x to the negative 6, 2 times 3, and y to the negative 3. So these are all going to end up in the denominator, 1 over 5 cubed, x to the 6th, y to the 3rd. And we can clean up the 5. 5 times 5 is 25, times 5 again is 125. X to the 6th, y cubed. Alright, so take a moment to pause this, and your job is to do 2, 4, 5, and 6. Make sure you're done with those before you press play and move on. Alright, so what does it mean to simplify expressions with rational exponents? So we are used to the radical form, right? Square root of 25. We can rewrite that in exponent form as 25 to the 1 over 2. Cube root, 1 over 3. Fourth root, 1 over 4. So you'll see that the fractional rational exponent form changes from the radical form. So if we don't want to use the radical, we can use fractional exponents. All right? And so let's take a look at some examples. 125 to the 1/3. Same thing as saying the cube root of 125. Our answer there is 5. 5 to the 1/2 times 5 to the 1/2, that's the same thing as the square root of 5 times the square root of 5, which is the square root of 25, which is just plain old 5. And then the next one, we've got the cube root of 10 times the cube root of 100. And since it's the same index, we can multiply the radicands, the 10 and the 100, and get the cube root of 1,000. And the cube root of 1,000 comes out nicely as 10. 10 times 10 times 10 is 1,000. So see if you can come up with the correct answers when you simplify for understanding check number 1. Alright, so let's take a look at our definition here. So if you have a to the 1 over n, whatever the n is our index. Alright? Now sometimes you're going to have a number on the top of this, an m, and if you have that, that's going to be the exponent inside with the a. Okay, so n is the index, m will go on the inside. So if we look at this first example, 2a, x to the 3/5, if we were to rewrite that in radical form, which is what this problem's asking us to do, we're going to have the 5th root, that's the denominator. Okay, so 5 is the index, 5 comes from the denominator, of x cubed. If we did b, before we can do that, we're going to need to rewrite this as y to the negative 7 over, sorry, not 7 over 2. 5 over 2. 5 over 2 is 2.5. Rewrite it as a fraction. And then what we have here is the square root, 2 from the denominator, of 1 over y to the 5th. Two things going on here. The m goes in here for the 5, and then the negative tells us to take our y and flip it over. Okay, so 1 over y to the 5th. Let's go the other way for b. if I have the square root of a cubed, that's going to be a to the 3 over 2. And if I have the fifth root of b squared, that's going to be b to the 2 over 5. Okay? And that would be the answer for B. All right, your turn. See if you can get A, B, and C for understanding check number 2. All right, so let's take a look at our real-world connection. Bone loss for astronauts on lengthy space voyages may be prevented with a bed-like apparatus that rotates to simulate the effects of gravity. Here's our formula. N equals a to the 0.5 all over 2 pi r to the 0.5. N is the rate of rotation in revolutions per second. A is the simulated acceleration in meters per second squared. And r is the radius of the apparatus in meters. How fast would an apparatus with a radius of 1.7, highlight the important parts, have to rotate to simulate the acceleration of 9.8 meters per second squared that is due to Earth's gravity? So let's plug it in. We're trying to find N equals, we know A now, the acceleration they told us is 9.8 to the 0.5 all over 2 pi r, and r we now know is 1.7, and that's also to the 0.5. So we're doing the square root of 1.7 and the square root of 9.8. Let's grab our calculators and see if we can clean this up here. So we've got 9.8 to the 0.5. That's that number. I'm going to do the 1.7 first. 1.7 to the 0.5 times 2 pi. And now I need to have the 3.13 divided by the 8.19. So let me approximate it. 3.13049 divided by 8.19227. And on your calculator, you're going to want to press the up arrow key to go grab those numbers. This simulated computer version doesn't do that, so we have to type them in. Press enter. You should get 0.38. Okay, and that's our answer for example 3. All right, so your job now is to change things. Calculate the rate of rotation needed for the apparatus in example 3 to simulate a gravitational acceleration half as strong as Earth. Remember, Earth is 9.8, so half as strong as that. So let's change our calculations and see what we get for the answer. All right, so quick review of everything we've learned about exponents. A to the m times a to the n, you add the exponents, right? 8 to the third plus 8 to the, or times 8 to the 2/3, you get 8 to the first. All right, if the exponents are in parentheses, we're going to multiply them. 1/2 times 4 gets us 2. All right, we could go, if we have 2 bases and a single exponent, we could split them up. 4 times 5 to the 1/2 is 4 to the 1/2 times 5 to the 1/2. Negatives mean flip over. 9 to the negative 1/2 is 1 over 9 to the 1/2. And we can subtract if we're dividing, right, to subtract the exponents. And then lastly, we're going to distribute into the numerator and the denominator if we have a fraction with an exponent on the outside. So, got to remember all those things. Let's try 4A and B. Let's see what we got here. Negative 32 to the 3/5. So, we got 5. We got negative 32 cubed. All right, so I think it's easier to make a small number big than it is to make a big number small. So what I mean by that is I always try to find the radical first and then cube. So if I think to myself, all right, what's the 5th root of negative 32? That answer is negative 2. 2 to the 5th gets me back to 32. But we still have this cubed here, so the cube sticks with us. So our answer here is going to be negative 2 cubed, which is negative 8. So first we do the 5, and then we do the 3. Same thing here for 4. This is 4 to the negative 7 over 2. So we're going to have 4 squared on the inside, and we're going to have, 1 over 4 squared because of the negative. And then we're going to have, I did this backwards. 2 on the outside, 7 on the inside. So Let's make it small first. The square root of 1/4 is 1/2. The 7 is still there. We've done this part, still got to do the 7. So 1 to the 7th is 1. 2 to the 7th, let's see, 2, 4, 8, 16, 32, 64, and 128 is 2 times 2, 7 times. That's our answer there. All right, your turn on 4A, B, and C. And let's wrap it up here with number 5, and we're going to introduce some variables here. Same rules apply. So let's distribute first. We've got 16 to the negative 3/4 times y to the positive. Now you'll notice a negative times a negative. 8 times 3 is 24 over 4. We'll deal with the 16 first, so it's going to be a negative, so 1 over 16 to the 3rd, and that's the 4th root. The 4th root of 16 is 2, so this is 1/2 cubed. 1/2 cubed is 8. Now, the nice thing about these fractional exponents is you can reduce them. Y to the 24 over 4 is the same as y. 24 divided by 4 is just 6. Nothing more we need to do there. There's our answer. 8y to the 6th. All right, so your job 5 for the understanding check, and your job here is done. Any questions? Make sure they get answered in class, and I will see you then.